an activity. What is a value expressed as a fraction of gamma for a monatomic ideal gas, for a linear molecule, or a nonlinear molecule? So I'm going to put this relationship up here again. CPm equals CVm plus R. We note that gamma equals CP, I'll just write CP divided by CV, CPm divided by CVm, same thing. So you can work through these with me if you like. Otherwise, I will play some music and work through them myself. Okay. I love this song. I could listen to this all day. Okay, folks, let's go ahead and talk about this. So hopefully this was fairly straightforward. And you remembered that CV for a monatomic gas is 3/2 R. CV for a linear molecule is 5/2 R. And CV for a nonlinear molecule is 3R. So these each have an additional whole unit of R for CP. And thus that gives you gamma for a monatomic gas is 5/3. I'm just going to express that as a decimal real quick for a quick comparison. So that's 1.67. We get gamma for a linear molecule is 7/5. So that's 1.4. Okay. And so we get that for the linear molecule, it's 4 divided by 3, which is 1.33. So the trend is there, that the value of gamma is decreasing with more degrees of freedom. Okay? And so the physical interpretation of that is on this curve, on these adiabats, the monatomic gas will fall off much quicker. So it's going to have a much steeper change in volume with pressure. And the reason for that is because it doesn't have as many degrees of freedom that need to be supplied with heat in order to fuel that expansion. Okay? So in other words, the nonlinear molecule, before it can even do any of that expansion work, that heat has to either get, pumped in or pumped out of those degrees of freedom before any change can happen. Okay? So hopefully that makes good physical sense to you. If not, we can most definitely talk about it more during office hours or during our live session. Okay? So now I think that this is a good time to stop. So you can see on the next video, we're going to talk about thermochemistry and standard enthalpy changes. So hopefully that will be some familiar ground for you all. Okay, folks, I'll see you in the next video.